Hello pre-calculus students, and welcome to a lesson on difference quotients. Okay, to find the slope of the secant line between 2 points in a function, we use difference quotients. Difference quotients are used with limits in the definition of the derivative in calculus and are important to understand. Sometimes they can be a little bit difficult to compute and simplify, and we'll see that here. We can simplify difference quotients into a formula for finding the slope of a secant line. So let's first look at a diagram here. So we have 2 points here drawn onto an arbitrary function f of x. Okay? Now the points have an x-coordinate a. If that's the x-coordinate, then the y-coordinate will be f of a. And if the second coordinate here is b, here on the x-axis is b, then you would have b f of b. Now if we look at this b as not its own value, but as a plus some distance h, then what we have here is we're looking at 2 points, a f of a, and b, I'm sorry, not b, a plus h. That's the x-coordinate is a plus h, comma f of a plus h. Okay, so if those are our 2 points, then to find the slope of those 2 points, we would take the difference in the y's, which would be f of a plus h, minus the other one, which is f of a, over the difference in the x's, which is a plus h, minus the other one, which is a. And this simplifies to the difference quotient that we're going to be working on first, which is f of a plus h minus f of a over h. Okay, so in the one that we're doing here in example 1, we're just replacing the a with an x. It's just the x-coordinate either way. Okay, so we're looking at a function f of x equals 3 minus 1/4 x, and we're going to find the difference quotient for that function. So notice there's 3 ingredients. I call them ingredients to the difference quotient. There's the f of x plus h, there's the f of x, and then there's the h. Okay, the f of x is given to us, so there's no searching for it. It's right here. The h is just a variable for now. Okay, and the f of x plus h is something that we learned how to calculate in the last lesson, so we should be able to figure out what that is, and that's going to be what I recommend to always do first. Before you do any difference quotient, first find f of x plus h. And f of x plus h would be 3 minus 1/4 of x plus h. That would simplify to 3 minus 1/4 x minus 1/4 h. There's your f of x plus h. All right, now when we write these 3 things down into our fraction, we're going to have a long fraction bar with the f of x plus h that we just found showing up first. So that's 3 minus 1/4 x minus 1/4 h. And then from that, we're going to subtract f of x, which is 3 minus 1/4 x. And that's all over h. Okay, now before we continue, when you're simplifying these difference quotients, you always want to be able to think what you're going to think in calculus, which is what would happen if h were 0. Because what we're looking at here on this diagram is called the average rate of change between 2 points. What you're going to look for in calculus is the instantaneous rate of change at 1 point. So what we want is we want these 2 points to be so close together that they're pretty much the same point. So we really want h to be 0. So what we want to be able to do is set h equal to 0. But we can't do that here because we would have a 0 in the denominator. Okay, so the beauty of the simplification of these is they will all allow you to make h equal 0. Even if we don't have to now, that's sort of one way to check to make sure you're doing things right. If that h can be canceled out of the denominator, you're in good shape. Okay, so let's go ahead and cancel what we can here. Let's distribute this negative sign right here. And so we have 3 minus 1/4 x minus 1/4 h minus 3. And then this gets distributed to the minus, so it's plus 1/4 x. And that's all over h. Okay, now you can see a couple cancellations. 3 minus 3 is 0. That just goes away. Negative 1/4 x and positive 1/4 x, they go away too. So all we're left with is negative 1/4 h over h. And there the h's cancel away like we need them to, and we just get negative 1/4. And that's the answer. This is pretty much the only type that you're going to see that simplifies to a single number. And if you think about it, you already knew the number, because what we're looking at up here, and this only happens for linear equations, the thing that's special about linear equations is their slope is constant. The slope does not change throughout the function. If you were to look at the slope of this curve, at this point the slope would be there. At this point the slope would be there. And pretty much any place that you look at the slope, it's going to be different. If you look at a secant, from these 2 points you're going to get that slope. But if you looked at between these 2 points, you're going to get that slope. And they're always different. So the slope is constantly changing for a curve. But for a straight line, the slope is never changing, it's constant. So we see the slope is negative 1/4, and it just kind of checks out something that we already knew. Let's look at one that's not linear. Okay, so here's a function that's not linear. And let's apply the difference quotient. Let's follow the suggestion that we're always going to find f of x plus h first. So f of x plus h is 5 times x plus h squared minus 3 times x plus h. So I'm going to have you simplify this as we did in the last lesson, and then I'll come back and show you the answer. Okay, so there's your f of x plus h. It's already a long problem, but we're not done. Okay, we found this, but now we have to put it all together into a difference quotient. So we're going to put what we just found in the numerator. So we have 5x squared plus 10xh plus 5h squared minus 3x minus 3h. And we're going to subtract now f of x. So we're going to subtract f of x, which is this thing right here, 5x squared minus 3x. And it all goes over h. And remember, in the end, we want that h to cancel. So 5x squared minus 5x squared, they cancel. This is really a plus 3 because you're subtracting a negative. So this negative 3x cancels with this 3x right here. And all we're left with is 10xh plus 5h squared minus 3h over h. And can we get rid of that h in the denominator? We can, because we can factor an h out of the numerator. We get 10x plus 5h, once we take an h out, minus 3 over h. And that's kind of the happy moment in these problems, when the h's cancel. And then our final answer is just going to be 10x plus 5h minus 3. And just a preview, in calculus, you're going to say, I wonder what would it be if h were 0. You're going to have 10x minus 3, and that's the slope, which changes throughout the function. If you were to look at this curve, the slope is changing just like it's changing in this arbitrary curve, and you would actually have the instantaneous slope. Okay, let's look at one more example, one with a fraction, and they're not easy with fractions. You have to get used to working with complex fractions. Okay, so let's take a look at what we have here. Let's start out with f of x plus h. That's not as bad this time as it was in the last one. It's just going to be 9 over x plus h minus 2. Now let's plug that in. So we have the difference quotient would be the f of x plus h first, which we just found. So 9 over x plus h minus 2. Subtract from that the function that we were given. So 9 over x minus 2, and the whole thing goes over h. Okay, so focusing on the numerator. So ignore the h down here for just a moment. Just ignore that for a moment. We want to simplify the numerator. And so what we need to do is we need to get a common denominator. Now, there is no factor that's common to both because these are both fully factored expressions. X plus h minus 2, you can't factor that any further, and you can't factor x minus 2. So therefore, all we can really do is multiply them together for our denominator. So the denominator of the numerator is going to be the product of those two, x plus h minus 2 times x minus 2. And to get that, you need to multiply the first fraction by x minus 2 over itself, and the second fraction by x plus h minus 2 over itself. Okay, when we do that, the denominator becomes what we have here. The numerator becomes 9 times x minus 2, and over here it's going to be minus 9 times x plus h minus 2, and that's still all over h. Okay, we're actually closer to done than it looks. It's just not going to look as pretty as we want it to look when we're done, but it will still simplify away that h. It will still accomplish that goal of getting rid of that h. So let's distribute twice in the numerator, and we have 9x minus 18 minus 9x minus 9h plus 18, right? Negative 9 times negative 2 is plus 18, all over that ugly denominator, x plus h minus 2 times x minus 2, and that all over h. We do get some cancellations in this numerator of numerators. We get the 9x minus 9x, we get the 18 minus 18, and we're left with just a negative 9h there. Now this can be thought of as h over 1. Why would I do that? Because I'm going to multiply it by the reciprocal. Okay, so I'm going to take my negative 9h, I guess I have room here to do it right here. So I'm going to take my negative 9h over my ugly denominator, x plus h minus 2 times x minus 2, and I'm going to multiply it by the reciprocal of h over 1, which is 1 over h. What happens? This h cancels with this h, and we just get our final answer, negative 9 over x plus h minus 2 over x minus 2. That's the final answer. Now, did we solve our problem that if we want h to be 0, we can do that? Yes, we did, because if h is 0, it's still defined in this final answer, while it wasn't defined when we had this in the denominator. Okay, so it actually worked. Okay, so we'll do a part 2 and look at the other difference quotient, but I hope that you found this video helpful.